7.1 Solving linear systems by graphing. A system of linear equations, also known as a linear system, is the combination of two or more equations. The solution to a linear system with two variables is the ordered pair x, y that makes both of the equations true. So let's test this. In this first example, we are going to determine whether the ordered pair 4, 2 is a solution to the linear system. In order for this ordered pair to be a solution, it must work for both equations. So we are going to plug x and y into both equations. So in the first equation, negative 4 plus 2 needs to equal negative 2. So we'll simplify this. This becomes negative 4 plus 2. Again, it needs to equal negative 2. Negative 4 plus 2 is negative 2. And does it equal negative 2? Yes. Now we can't just say that it is a solution since we had one true test. You have to test both equations. So let's go ahead and plug in x and y into the second equation. 2 times 4 plus 2 equals 10. 2 times 4 is 8, plus 2 needs to equal 10. 8 plus 2 is 10, and it does equal 10. So the question, is 4, 2 a solution to the linear system? Now we can actually say yes. In this chapter, we will be learning 3 different ways to solve a linear system. And in this section, we will be determining the solution through graphing. Just by looking at the graphs of 2 lines, where do you think the solution is? Where is the ordered pair that both equations share? Looking at the graph, hopefully you notice that where they intersect or cross is the solution. It is the ordered pair that lie on both lines. So why don't we go ahead and make ourselves a little note that the solution is at the point of intersection. Again, it is the ordered pair that exists on both lines. Now looking at this graph of our linear system, I can tell that the solution to this system is at the ordered pair 2, negative 1. So right here where it says determine the solution to the given linear system, we would say that the solution is 2, negative 1. Okay, let's begin to solve a linear system by graphing. There are different steps. The first step is to take each equation and make sure that it's in slope-intercept form so that you can graph it. Now, in this first example, both equations are already in slope-intercept form. Remember that means y has to be by itself. Now, in order to graph our lines, we need to know what the slope is and what the y-intercept is. In this first example, our slope is 1 and our y-intercept is 0, negative 3. Our other equation has a slope of negative 1 over 2 and a y-intercept of 0, 3. So now we can go ahead and graph both lines. So the first thing we have to do is graph the y-intercept. So 0, negative 3 is here with a slope of 1, which means up 1, right 1, up 1, right 1. And the more points you graph, the more accurate your line will be. It will also be easier to see where the lines intersect when we draw our other line. So there we go. I'm going to go ahead and draw my line. That is the first equation. Now we have to draw the second equation. So I'll go ahead and do it in a different color. So the ordered pair for our y-intercept is 0, 3, which is here. And we have a slope of negative 1/2, which is down 1, right 2, down 1, right 2, down 1, right 2. And I could keep going, but I really don't need to since I can see where my lines have already crossed. So the next step is simply to identify that ordered pair. And again, if I look right here, this is where the two lines intersect, which is an ordered pair of 4, 1. So the solution to this problem is 4, 1. Now we can check our solution and make sure we're right by plugging it back into the original equations. So the first equation is y equals x minus 3. So we're going to take 4, 1 and plug it in. So y is 1, x is 4, and we need to know that 4 minus 3 equals 1, and it does. Now remember, you have to check both equations. The other equation, let me just scroll up a second, was y equals negative 1/2 plus 3. So again, whoops, I forgot my x. So there we go, negative 1/2 x plus 3. Again, we're going to go ahead and plug in x and y. So y is 1 equals negative 1/2 times x, which is 4 plus 3. So negative 1/2 times 4 is negative 2. So we need to know that negative 2 plus 3 is 1, which it is. So again, we have a true statement. So remember, if you're not sure if you have the right ordered pair for the solution, you can always check by plugging it back in to the original problem. Let's take a look at the second example. We're going to solve this system. Now, in step 1, we said you have to make sure both equations are written in slope-intercept form. In example 1, they were, but in this example, they're not. So the first thing that we need to do is rewrite these equations in slope-intercept form. So our first problem is x plus y equals negative 2, and we have to solve for y. So subtract x from both sides, and we're left with y equals, put your minus x first, and then minus 2. So here our slope is negative 1, and our y-intercept is 0, negative 2. All right, let's go ahead and take a look at the second equation. We've got 2y minus 6x equals 4. Getting y by itself, we need to add 6x to both sides. And we're left with 2y equals, put the positive 6x first, and then a positive 4, so we put plus 4 next. Last thing we need to do is divide everything on both sides by 2. And that would leave us with y equals 3x plus 2. Our slope is 3, and our y-intercept is 2. So now we can go ahead and graph our lines. So our first line, again, has a y-intercept of 0, negative 2, with a slope of negative 1, which means down 1, right 1, down 1, right 1, down 1, right 1, and I could keep going. I could even be going the other way, up 1, left 1, up 1, left 1, so that I have points going in both directions. So here is my first line, and now I have to draw my second line. So my y-intercept is 2, and I have a slope of 3. So up 3, right 1, up 3, right 1, or again we can go down 3, left 1, down 3, left 1. Now again, we don't have to go any further because hopefully you can see where the 2 points intersect. And that point of intersection would be -1, -1. So the solution to this system is -1, -1. All right, let's go ahead on to the next example. Example 3. Let's go ahead and solve this system by graphing. Okay, first we have to rewrite the first equation again into slope-intercept form. So our first equation, or our top equation, is x plus 3y equals 12. And we have to, again, solve for y. So we're going to subtract x from both sides of our equation, and we left with 3y equals, put the minus x first, and since it's a positive 12, we write plus 12. Divide everything on both sides of the equation by 3, and we get y equals, remember that a negative x over 3 is the same thing as a negative 1/3 x, and 12 divided by 3 is 4. So this is our new equation, and our slope is negative 1/3 with a y-intercept of 4. All right, let's go ahead now and take a look at the second equation. Our second equation, also the bottom equation, is negative x plus 3y equals 6. Add x to both sides of the equation, and we'll be left with 3y equals a positive x plus 6. Divide everything on both sides of the equation by 3, and we're left with y equals, just like in the last example, x over 3 is the same thing as 1/3 x plus 6 divided by 3, which is 2. Here we have a slope of 1/3 and a y-intercept of 2. So let's go ahead and graph these. The first one I'll go ahead, since I'm already in the red pen, we've got a y-intercept of 2 with a slope up 1 over 3, up 1 over 3, or we can go the other way, down 1, left 3, down 1, left 3. And I can go ahead and connect my line. All right, now I'm going to go ahead and graph the other equation, and that is a y-intercept of 4 with a slope of -1 over 3, down 1 over 3, and I can stop because my lines have already crossed. So I'm going to draw my line, and I can identify my solution, and that would be right, oh my gosh, these were terrible lines that I drew, but right there is where they should cross, and that ordered pair is 3, 3. All right, let's go on. Oh, we got a question. All right, if the two lines that you graph are parallel, what do you think the solution would be? So the key thing here is to think about what parallel lines are. Remember that parallel lines are lines that never intersect. So let's write that, lines that never intersect. And when we first started talking about our linear systems, we said that the solution is at that point of intersection where the lines cross. So if two parallel lines, for example, are looking like this, they never intersect. So is it possible for this problem, for a problem like this, to have a solution? No. So if you have two lines that are parallel, you will have no solution. All right, so let's go ahead and keep doing some more practice. In this example, go ahead, try to get each equation into slope-intercept form, graph both lines on the graph, and then see where the two lines intersect. Once you are finished, try plugging in your solution to the original equations to see if you are correct. If you're not, try again. Once you have finished, go on to the next problem. Again, try to do this on your own, Put both equations in slope-intercept form, graph them on the coordinate plane, see where they intersect. Once you have finished, check your solutions. Now I'm going to go back to the first example that you were going to do on your own. So if I go backwards, now here we go. Now for this problem, the first equation you should have written as y equals negative x plus 5, which means it has a slope of negative 1 and a y-intercept of 5. So if we go ahead and graph that, that's going to be here, and our slope is negative 1, so our line will look something like that. And in the other equation, you should have y equals 2/3 x minus 10. So a slope of 2/3 and a y-intercept of negative 10. So if I graph that, negative 10's down here, we're going up to right 3, up to right 3, up to right 3. Okay, well now I've got to make sure that this one is as accurate as possible. So I'm going to go back to my red line and do down 1, right 1, so that I can see where exactly those points are since I stopped. And now hopefully you can see that my lines, whoops. Alright, did that stop recording? No, it didn't. Okay, so hopefully you can see that my lines intersect right here at that point, which is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4. So the solution here looks like it is 9, negative 4. Alright, in the next example that you did on your own, you should have for the first example that y equals negative 3x minus 2, slope being negative 3, y-intercept being negative 2. And then in the second equation, you should have y equals negative 3x plus 5. So a slope of negative 3 and a y-intercept of 5. Now, some of you may remember from previous chapter that if two equations have the same slope, it means they're parallel. So let's just write this because these are our notes. Parallel lines have the same slope. Have the same slope. And remember that big brain question we just asked a few seconds ago? Well, if lines are parallel, we know that they have no solution. So you didn't even need to graph this problem. Alright, now that you are finished, go ahead, turn off your system, and go and ask for your assignment for today.